In this video, I'm going to show you how quick and easy it is to set up BGP on your Fortigate firewall, even if you're a beginner. And so the aim in this first part of the video is to get this entire network fully converged and every device being able to reach every other device. At the very top of our topology, we have two data centers. We have our primary data center in blue and our secondary data center in orange. The primary data center is always going to be the active data center, and we're always going to be advertising the 100-100 network from behind firewall 1. But of course, if something goes wrong with the primary data center, we want for the secondary data center to kick into place in the event that the primary data center fails. So firewall 3, 4, and 5 represent the branches. R1 and R2 represent two ISPs that are not interconnected in any way. So each site is multi-homed. All right, let's hop onto firewall 1 and start configuring BGP. I'm on firewall 1. We go to network, BGP, and our local AS is 65510. 65510. And our router ID is going to be 10.10.10.10.10. Oh, too many 10s. So our local AS is 65510, and I'm going to use the last two digits as our router ID. In this case, we also have the address configured locally on each of the firewalls. For instance, firewall 2 in the ASN 65520 is going to have a loopback address with an IP address 20.20.20.20. We're going to use that also as a router ID, and the same logic applies to firewall 3, 4, and 5. Each of the firewalls has a connection over a /30 network to R1 and R2, and each of the firewalls would be the .1 in the segment, and the routers would be .2. So in this case, our neighbors are going to be the IP address of R1 10.160.10.2, and the remote AS is 65501. And then now to R2. R2's IP is 10.160.20, 10.160.20.2 with the remote AS of 655.20. So the first thing was the local AS, then the router ID, then the neighbors, and then the networks. We're going to advertise three networks. We're advertising the directly attached network the network links, as well as the network that we want to advertise that we're originating into BGP, being the 100 network. So there's three networks to advertise: 10.160.10.0/30, as well as 10.160.20.0/30. And now for the 100 network, 100. This one is a /32. And just like that, we're done on firewall 1. Now let's hop on to firewall 2. Now we're on firewall 2. Our local AS is 65520. Our router ID is going to be 20.20. From the viewpoint of firewall 2, our neighbors would be 10.160.30 as well as 10.160.40. 10.160.30.2, and the autonomous system number is 65501. 65501. (10.160.40.2), and the autonomous system number there is 65502. This looks about right. Now we advertise our networks, starting with the directly attached network segments being 10.160.30.0/30 and 10.160.40.0/30. And again, we advertise the 100 network A/32. This looks okay. I'm happy with firewall 2. Now we move on to firewall 3. Okay, we are now on firewall 3. Our local AS is 655.13, and our router ID is going to be 30.30.30.30, and our neighbors is 10.160.50 as well as .60, 50.2 in the autonomous system number 65501. That's R1, and R2 would be 10.160.60.2 in the autonomous system number 65502. That looks okay. I'm happy with that. The networks that we're going to advertise would be 10.160.50.0/30, being the first IP segments connecting firewall 3 to R1, 10.160.60.0/30 as well. Last but not least, our loopback interface 30.30.30.30. This is a /32. I'm satisfied with this config. I think we can move on to firewall 4. I'm now on firewall 4. With firewall 4, the local AS is 65514. 65514, and the router ID is 40.40.40.40, and our neighbors would be 10.160.70 and 10.160.80. So that's 10.160.70.2 as well as 10.160.70 .80.2 with the remote AS of 65502. That's R2. And once again, the networks that we advertise in this case would be 40.40.40.40/32. That's our loopback address, which we're also using as our router ID, by the way. 10.160.70.0/30, 10.160.80.0/30. I know I did it a bit in reverse, but it works. Okay, I'm satisfied with this config. I think we can move on to firewall 5. Save our config. We are now on firewall 5, which is also our last firewall. Our local AS for firewall 5 is 65515. 65515, and our router ID is 50.50.50.50, and our neighbor would be 10.160.90.2, 10.160.90.2. That's R1 in the autonomous system number 65501. That looks okay. Now for R2, R2 is in the 10.160.100.2 and the autonomous system number 65502. I'm happy with this. Now we need to advertise these network segments, 10.160.90.0/30 as well as 10.160.100.0/30, and of course the loopback address 50.50.50.50. That again is a /32. So now that we're done with our BGP configs, let's verify our configs by looking at the route table. And then in the route table, regardless of where we're looking at the routing table from, I expect to see the 30 network, the 40 network, as well as the 50 network. But of course, now we're on firewall 5. We might as well have a look at the route table from firewall 5. So since we're on firewall 5, we're not going to be learning 50.50.50 from BGP. So if I show the BGP table, if I display the route table from BGP, like filtering only with BGP, I'm not going to see the 50.50.50. And right now I'm only interested in the routes that we've learned via BGP. And the way to do that is get router info, routing table, BGP. It says no route available. Get router info, BGP summary. Okay, our BGP config is correct and we are connecting or trying to pair with 10.160.90.2 as well as 10.160.100.2. Let's see if we can ping them. Exec ping 10.160.90.2 as well as 10.160.100.2. Yep, we can ping them. Let me have a look at our router config on firewall 5. Get router BGP. Show router BGP. We have our autonomous system. Our autonomous system number is wrong. Our autonomous system number is not 65501. It's 65515. There's the first mistake over there. Let's correct that. Config router BGP. Set AS to 65515. Now that we've fixed our BGP autonomous system number, let's have a look and see if our BGP is up. Get router info BGP summary. And yes, our BGP is up. We have 2 peerings with 160.90.2, 160.100.2, and we are learning 14 prefixes from both. So I'm happy with this. Now let's have a look at the route table. Get router info, route table, BGP. So in summary, to get to where we are right now, to get BGP to be fully converged like it is, we've had to configure router ID, we had to configure autonomous system numbers, we've had to specify our peers with each with their own autonomous system numbers, and we've had to advertise our networks. The networks that we've had to advertise are the directly attached links connecting us to the adjacent neighbors, as well as local route that we are originating into BGP. In this case, it's the loopback addresses. Firewall 3 is originating the 30 network, Firewall 4 is originating the 40 network, and the Firewall 5 is originating the 50 network. In my view, I think our BGP has converged. We can now move on to other things. The next topic I want to talk about is BGP soft reconfiguration. It is best practice, it's highly recommended. Every time you configure BGP, you must include the BGP reconfiguration commands so that you can get a lot more out of BGP functionality. And I'm going to explain it this way. There's 2 important things. Number 1, when you have BGP soft reconfiguration, you are now able to, from, let's say we're on firewall 5 right now, we can request route updates from router 1 and router 2. We don't have to wait for timers, and if there's policy updates, if something has changed, we can request updates from our upstream peers. And route refresh actually does this without flapping the neighborships or adjacencies. And the second thing, which is equally important, is the ability to see the individual prefixes being advertised by your adjacent neighbor. So for instance, since we're on firewall 5, if we wanted to see the specific prefixes that R2 in particular is advertising, sending in our direction, is advertising to us as firewall 5, we need the soft reconfiguration enabled, and without this we won't be able to. In fact, let's have a look at that now. Get router info neighbor. In this case, our neighbor is 10.160.100, 10.160.100.2. And the command is received routes. We get an error message. It says inbound soft reconfiguration not enabled, no prefix for neighbor. So BGP doesn't know anything about the routes and the prefixes being sent and exchanged between firewall 5 and R2, and the same applies to the entire topology. So let's change this. I'm going to now configure soft reconfiguration on all the firewalls, and then we'll do this again back here on firewall 5. Let's start with firewall 5 to enable the soft reconfiguration. We go to config router BGP, config neighbor. You do this under the neighborship configuration hierarchy, and since we have two neighbors, I'm going to say edit 10.160.90.2, set soft reconfiguration enable. And then on to the next one, edit 10.160.100.2, set soft reconfiguration enable. Now soft reconfiguration is enabled. Let's run our commands again and see if there's any difference. Get router info, BGP neighbors 10.160.90.2, received routes. And with that command, you can see all the networks that have been advertised to us from 10.160.90.2. And we want to run the same command, and 10.160.100.2 would be R2. Let's have a look at that there. This is priceless in the corporate environments because you cannot troubleshoot BGP if you don't understand where the networks are being learned from. So this is one of the most important configuration you could have in BGP, and without this you'd be flying blind. So now it's time to run the same command to enable the same command on all the firewalls. Okay, I'm on firewall 4 now. Config router BGP, config neighbor, and I'm going to edit the first neighbor, set soft reconfiguration enable, the second neighbor, 70.2, set soft reconfiguration enable. Let's have a look. So I'm happy with this for now, and let's run the command and have a look. Get router info BGP neighbors 10.160.70.0, received routes. Get router info BGP neighbors received routes. So the command works. I'm on firewall 3. I'm going to connect over to the console, config router BGP, config neighbor, and edit the first one, set soft reconfiguration enable. That was 10.160.50. this is now 10.160.60. set soft reconfiguration enable. Both our neighbors, both our peers now have soft reconfiguration enabled. I think that's it for the route refresh or the soft reconfiguration. We now know that it enables us to on demand request updates from our upstream neighbor or BGP peer. And the second thing is the fact that we're able to now see the prefixes that we're learning from our adjacent neighbor or our BGP peer. Now let's move on to the next topic. The next topic is load balancing. If you take the route table and compare it to the network diagram, we can see that it doesn't actually correlate, and we see that with 100 network, firewall 3 is learning this from 10.160.60.2 via port 2. That's a link to R2. Let's have a look at this network and then see where it's being advertised from, which AS has originated this network. Get router info BGP network 100.100.100, and looking at this output, we can see that we have two paths to reach the 100 network, and these two paths have identical metrics. The AS path is the same, the origin is IGP on both, the metric is 0 on both, the local preference is 100, they are both valid, and they are both external prefixes. And so by definition we have equal cost multipath, but the equal cost multipath or load balancing is not enabled by default on the Fortigate BGP implementation. We manually have to enable that. All right. Since we're on firewall 3, let's start on firewall 3 to enable load balancing. And to do that, we go into BGP configuration. Config router BGP. Set eBGP multipath enable. And that's all we need. That's just one command. That is on firewall 3. Now let's go to firewall 4. We're back on firewall 4. Let's go into the console. Config router BGP. Set eBGP multipath enable. eBGP multipath is enabled on firewall 4. Now we move on to firewall 5. We're back on firewall 5. Let's enable eBGP multi-hop. Config router BGP. Set eBGP multipath enable. Alright, now that it's enabled, let's have a look at our route table. Get router info, routing table, BGP. It looks like our prefixes haven't been updated yet, so now we do have the soft reconfiguration enabled. Let's request an update. Oh, it looks like it worked even before I did the route update or the route refresh. Now looking at this output, we can see that BGP has allowed multipath where multiple paths to a network exist. We have multiple paths leading to the 30 network, multiple paths leading to the 40 network, and multiple paths leading to the 100 network. So in this case, the traffic is going to be load balanced between 10.160.90.2 as well as 10.160.100.2. So traffic will exit via port 1 and port 2. And the way the load balancing works by default, if you don't choose any other load balancing algorithm, the default load balancing mechanism is based on source IP address. And that's also important for the exam to remember. So I want to go back and look at the network 100 a little bit closer. So get router info BGP network 100, 100, 100, 100. I want to look at this and try and figure out why is it that this second prefix has been chosen as the best, whereas this equal cost to this network via the two paths. And like we said earlier, pretty much everything is the same. So one of the ways in which BGP makes a decision about which route is going to be entered into the route table for a specific prefix is based on age. So here we can see that 10.160.100.2 should in fact be the preferred path, but it's not. And if we look at this path from 10.160.90.2, the thing that stands out, the only thing that is different, is the fact that 10.160.90.2 is the oldest BGP neighborship for this prefix, meaning 10.160.90.2 presented the 100 network to firewall 5 a lot earlier than the 10.160.100.2. And with that, I think this is the last thing I wanted to cover in relation to load balancing. Now we're going to move on to other things. So we said that there's 4 things that are absolutely critical for you to have a successful BGP peering. That is the router ID, the ASN, your BGP peers with their specific ASNs, as well as the networks. But I want to focus on the router ID. Like I mentioned before, the router ID doesn't actually have to be an IP address configured on the router or on the firewall. But it helps because if you have that IP address configured, then the likelihood or the chance of having an IP address conflict or conflicting router IDs becomes very slim. So yes, router ID is just a label, it's just a tag, but an important one. And in fact, it's so important that BGP uses router ID in its decision-making process when it evaluates the prefix. If there's a tie, BGP is going to use the router ID as one of the tiebreakers to decide which originator is going to be entered into the route table as the source for the network that is being advertised. And with the router IDs, the higher is better. The other thing that I want to stress is the autonomous system number. If you have the same autonomous system number with the BGP peer that you're connecting with, that you're peering with, that will be considered an iBGP, meaning an internal BGP or interior BGP. And with iBGP, the metric is 200. But of course, in this lab, each device is in its own autonomous system. That makes it an eBGP peering. And eBGP has a default admin distance of 20. So in this last section, we're going to pivot a little bit. We're going to do a little bit more advanced stuff. And yeah, we are going to do traffic engineering. We want to configure primary data center as the primary data center. It must be preferred. The secondary data center, it must be less preferred than the primary data center, so that the traffic is always going to be forwarded out towards firewall 1. But before we do that, I want to look at the BGP decision tree. The number 1 item on the list would be weight. Weight would not be scalable, so weight is out. The next attribute that BGP is going to look at is local preference. Local preference is only relevant in eBGP, where all the routers that are speaking BGP are in the same autonomous system. And then the preference would be useful in that sense, because it can then be communicated between BGP peers. But in this case, we don't have eBGP anyway in our network, so local preference is out. So that makes origin the next attribute that BGP is going to consider. In relation to the network 100, firewall 1 actually has an IP address configured locally, and it's advertising 100 network into BGP. It's not originated from somewhere else, it's originating this network. So the origin is going to be IGP, but that also applies for firewall 2. That means the origin is the same, it's going to be IGP. So there's a tie there. Taking us to the next one, which is AS path. Now this is where I get excited, because AS path is relevant in this deployment because it is mandatory, which means all the route updates, all the prefixes that are being exchanged between routers, either internally or externally, those prefixes must be, when they get transmitted, this information, the AS path information, must be transmitted along with them. Meaning not only is it mandatory, but it's also transitive. And if it's transitive, then it gives you a lot more flexibility to influence everybody else downstream. And in this topology, this is exactly what we're going to use. We're going to use AS path to steer traffic towards the primary data center, and we'll use AS path to steer traffic away from the primary data center towards the secondary data center. And to do that, we first need to create our prefix list to match the 100 network. I'm back on firewall 1. Let's create our prefix list. I believe this gets clearer when we do it in practice. Config router prefix list. Let's give it a name. Let's say network 100. Let's configure some rule. Edit the first one. Let's say set prefix to 100.100.100.100/32. I'm just going to leave it at that. Show router prefix list. Our prefix list only has one rule. I'm happy with that. It serves the purpose right now. And the next thing that we need to do is define our route map. I'm just going to call it set secondary. Config router route map. Set secondary. Config rule edit 1. So before we write the rule here in the route map, we need to remember that if the AS path is longer, it's not going to be preferred. BGP is always going to prefer the AS path that is as short as possible. Meaning if you want to influence BGP not to prefer a specific path, you need to poison that path. You need to make that path appear as if it has a longer AS path to get to the destination. So right now we are in our route map. Let's match our prefix list first. Set match IP address, and because we already have our prefix list, it's there as an option to choose. So we match with IP address net 100. Now the action that we want to do is we want to prepend 100, 200, 300. AS path action would be to prepend. Let's have a look at it in reverse. Our route map has a name. We call it set secondary, and it's going to match an IP address defined in the prefix list called net 100. So we're saying in relation to this network, wherever we're going to advertise this network, net 100, add 3 autonomous systems in addition to the real autonomous system. So now we have this route map. It's matching this network, and it's going to take these actions. So we're on firewall 1. We need to apply this to our BGP peering with R1 and R2. Now we have this. Let's apply it to our BGP config and just take it one step at a time. config router BGP, config neighbor, edit. The first neighbor is 10.160.10, which is R1. Set route map out, because we want to advertise it out. We have the 100 network, we're advertising out that network to R1 and R2, so the command is set route map out, and we specify our route map, which is set secondary. We do the same for R2. Set route map out, set secondary. Show router BGP. When we look at our BGP peering with 10.160.10.2 and 10.160.10.20, we can see that we've applied the route map in the outbound direction, meaning R1 and R2 should be receiving that information from us now. But yes, of course, we don't have access to R1 and R2. Let's have a look at firewall 3 and see if firewall 3 has learned anything about this network. I'm on firewall 3 now. Get router info. BGP network 100.100.100.100. We still haven't got an update regarding the 100 network because we're still seeing this being advertised from 65510. So let's try and do our route refresh. Exec router, clear BGP all, soft in, and then let's run our BGP network command again. Maybe I need to run the command in the outbound direction on firewall 1. Exec router, clear BGP all, soft out, and let me run this command again in the inbound direction, and then let me run the command again to have a look. Okay, let's try again, and this time you can see the final destination is AS 65520. So firewall 3 is now following a path via 65501, which is R1, and 65502, which is R2. But in the end, it's going towards 65520, which is the secondary data center. And if we look at firewall 4 and firewall 5, we're going to see exactly the same. Get router BGP network 100.100.100.100. Yes, as we expected, we are seeing this network being advertised through 65520, meaning behind firewall 2 in the secondary data center. I'm going to SSH into 100.100 just to be 100% sure that this is firewall 2 that we're talking about. Execute SSH 100.100.100.100. And indeed, it is firewall 2. I've logged out of firewall 2 just to be 100% certain that our concepts actually work the way we intend for them to work. I'm going to offload route map from the BGP peering with R1 and R2 on firewall 1 to make sure that that route map is not applied anymore. And then I'm going to create the same route map on firewall 2, because right now all the traffic to the 100 network is going to firewall 2. If I create this route map with the long AS path, the traffic should be redirected back to firewall 1. Now, what I'm going to do is create the same route map on firewall 2, and I'm going to prepend 4 autonomous systems. On firewall 1, I appended 3. On firewall 2, I'm going to append 4. So that's going to mean that firewall 2 now has a long AS path for the destination 100 network, making firewall 1 more preferred again. And so we should see in a couple of seconds, we should see the traffic be redirected to firewall 1. And for us to do this, I need to connect to firewall 2 and do my configs there. Okay, the first thing is the prefix list to define our 100 network. Config router prefix list, and I'm going to call it network 100. Config rule edit 1, set prefix 100 100 100 100 /32, and that's it for our prefix. Let's have a look at it. Show router prefix lists. It looks good to me. And now we create our route map. Config router route map. Our route map, I'm going to give it the same name. Set secondary. I'm going to configure the rules, and the first one, set match IP address net 100, set AS path action prepend, set AS path to, I'll just say 1000, 2000, 3000 and 4000. Show router route map. Our route map prepends 4 autonomous systems, and now I'm going to apply this in the outbound direction from firewall 2 to R1 and R2. Config router BGP, config neighbor, edit the first neighbor, set route map out, and the route map name is set secondary. The second neighbor 10.160.40.2, set route map out, and the name set secondary. And I believe this is all we needed. Okay, we're back on firewall 4. Let's check where the 100 network is being advertised from. Get router info, BGP network 100 100 100 100. I need to type this in full. So according to this prefix, we can see that the traffic will go 65501, which is R1 path, and 65502 via the R2 path, but in both instances they'll end up in 65510, and the networks, the AS paths that we prepended are still in place. 100.200, 100, 200 and 300. We know that from firewall 2 we prepended 1000, 2000, 3000 and 4000. So this part is a little bit shorter than the part that we prepended on firewall 2. And just also for the sake of completeness, let's SSH into the 100 network to make sure that we're going to be seeing firewall 1 when we do. Exec SSH 100.100.100. And yes, we are on firewall 1. I believe we are now at the end of our section 3, which concludes this video. I want to thank you so very much for supporting the channel and sticking with me through this video. I hope you can join me in my next video. This video was for BGP. In the next video I'm going to be doing OSPF, and it's also going to be a comprehensive deep dive video like this, aimed for absolute beginners but doing some really advanced things in the end. With that, thank you. See you in the next one.